You know, from the very beginning, when we first looked up at the stars, there's always been this pull, hasn't there? This inherent ambition, this curiosity about what's out there.
Absolutely. It's deep within us, I think.
For ages, it was just myths, dreams, but then something changed. We started actually doing it, taking these incredible, audacious steps beyond Earth. We're trying to figure out the cosmos, sure, but also, maybe, our place in it all.
Mm-hmm.
So today we're doing a deep dive into those moments, those really pivotal points that didn't just mark the journey, but actually launched us, literally, into the stars. And they changed everything down here, too.
Yeah, and that's the fascinating part, isn't it? These aren't just, tech demos. Each one was a huge shift, a seismic shift, really. Not just in engineering, but in how we saw ourselves, our potential.
Right.
They changed politics, they inspired generations, they built the foundation, piece by painstaking piece, for everything that came after. So yeah, our mission today is to pull out the key bits from this incredible story, understand those turning points that really mattered.
It's quite a story. Huge risks, unbelievable successes. We're going to walk through it chronologically, see how humanity's reach expanded. And the very first big one, the one that kicked it all off, it sent, well, shockwaves around the globe. A mix of awe and maybe a little anxiety. And it started with just a simple metal ball.
Okay, let's unpack this. Sputnik 1. It's hard to really overstate the impact. October 4th, 1957, the Soviet Union launches it. And it was basic, intentionally so.
Yeah.
Just a polished metal sphere, maybe, beach ball size?
About that, yeah.
58 centimeters, 4 long antennas sticking out. Inside, just a radio transmitter. Its whole job was to orbit Earth and beep.
Beep, beep, beep.
Exactly. That simple sound, on frequencies anyone with a ham radio could pick up, suddenly became the soundtrack for a new age. It wasn't just tech, it was psychological. Everyone listening knew the Soviets had done it. Space was reachable.
That's such a key point. It wasn't complex. It was a signal, a challenge, really. And boom, the Cold War space race was on, full tilt. I remember reading Eisenhower was like playing golf when he heard. Suddenly space wasn't theory, it was real, and it was a competition. The world was just stunned. This little thing up there defying gravity, it proved space was possible, and maybe more importantly, that someone else got there first. A huge cultural, geopolitical shock.
It really was. It proved that a nation could project its presence, its power beyond Earth. For the West, it was a wake-up call, challenged all the assumptions about technological leadership.
And led to massive investment. Right.
Yeah.
NASA was formed the next year.
Exactly. NASA, huge funding boosts for science education, like the National Defense Education Act in the U.S. The race was well and truly on. National pride, security, it was all on the line.
Okay, so from an object, a beeping sphere, the next leap was just staggering, putting a person up there into that, terrifying unknown. If Sputnik opened the door...
This was walking through it.
Yeah. Here's where it gets really interesting, because that jump from metal ball to living person, that took incredible guts, a massive leap of faith.
Absolutely. And again, the Soviets did it first. Just 4 years later, April 12, 1961, Yuri Gagarin, 27 years old, the first human in space.
Wow.
Aboard Vostok 1. He did one full orbit. The whole trip, just 108 minutes, launch to landing, less than 2 hours. But the impact, immense.
Can you even imagine, strapped in that tiny capsule on top of that massive rocket? No guarantees.
Not at all. And fun fact, he actually had to eject from the capsule near the end and parachute down separately. People sometimes forget that part.
108 minutes, less than 2 hours, like you said. And it changed everything about how we saw ourselves. It wasn't just, can a human survive space? It proved we could function up there, exist off-planet. It broke a barrier that had stood for all of human history, his famous Pokali, let's go. That became this global shout of excitement, didn't it?
It really did. Gagarin's flight proved definitively that humans could handle spaceflight, survive the G-forces, the radiation, zero-G, and actually do useful things. It wasn't science fiction anymore. It became the absolute bedrock for every human mission that followed. Longer flights, spacewalks, space stations. It all started there.
Okay, speaking of audacious goals,
Yeah.
if there's one moment everyone knows, the one image that just screams space exploration, it has to be the next big one. Orbiting Earth was amazing, but stepping onto another world.
The moon landing.
Apollo 11, the ultimate moonshot, the absolute peak, maybe, of that ambition.
Yeah. Summer of '69, NASA's Apollo 11, fulfilling Kennedy's promise from earlier that decade, land a man on the moon, bring him back safely. And the scale was immense.
Huge.
Over 400,000 people involved. Scientists, engineers, technicians, a truly national effort. July 20th, 1969, The lunar module, the Eagle, with Neil Armstrong and Buzz Aldrin inside, touches down.
While Michael Collins is orbiting above.
Right, the often forgotten astronaut, Michael Collins, orbiting in the command module, Columbia, their lifeline back home. Talk about pressure. Apollo 11 wasn't just launching a rocket, it was this incredibly complex dance of systems, logistics, risk management on a scale never seen before.
And then, those words. Armstrong stepping onto the surface. That's one small step for man, one giant leap for mankind.
Chills. Still gives you chills.
Broadcast to, 600 million people, something like that. It wasn't just a sentence, it was proof. It grabbed everyone, united people across the world in just the shared moment of awe. Humanity did this. We did this.
Exactly. And the effort behind it is just as staggering. Years of research, unbelievable political will, massive public support. It took all of that. It's still celebrated, not just for getting there, but for showing what happens when we, really commit to something huge. It redefined possible.
And that sense of wonder, that audacity from missions like Apollo, it really taps into that ongoing human drive, doesn't it? If stories like these spark your own curiosity, if you want to dive deeper into the science, the history, or even look at what's next, like trips to Mars.
Because it never really stops, does it?
Oh.
Each achievement just opens up more questions, new frontiers to explore. There's always more out there, more to learn about the universe and about ourselves.
And you can definitely keep that curiosity going. You might want to consider joining CuriosityStream. It's a top platform for streaming amazing documentaries. They have thousands of titles, tons of exclusive stuff about space and science. It really brings the cosmos right to you. You can watch it whenever, wherever. It's full of content from brilliant thinkers and filmmakers. Check out the link in the description to start exploring the space wonder.
Okay, so after these incredible firsts, first satellite, first man, first steps on the moon, the thinking started to shift a bit, right? Towards staying power, reusability.
That's right. A move towards making space access more routine, more sustainable.
Which brings us to a whole new era, moving beyond these spectacular but often one-off missions, towards building something more permanent up there.
Exactly. This was a really big shift. For decades, rockets were basically disposable, use once, throw away, incredibly expensive, hundreds of millions, even billions per launch, very complex logistics.
Right.
But then, 1981, NASA launches the Space Shuttle Columbia, and that was the first reusable spacecraft. That was the game changer. Reusable. How did that work exactly?
Well, parts of it came back. The two big solid rocket boosters, they'd parachute into the ocean, get picked up, fixed up, and used again. And the orbiter itself, the plane-like part with the main engines, that landed like an airplane and could fly again. It wasn't just about going up. It was about coming back ready for the next mission.
And the shuttle program ran for a long time. 3 decades, 135 missions. So it wasn't just about saving money, though I guess that was part of it. It was about what that reusability allowed them to do.
Precisely. It opened up totally new possibilities for working in low Earth orbit. Astronauts could now go up, do complex jobs, deploy satellites, even repair things in space.
Like the Hubble telescope repair? That was amazing.
Exactly. That's probably the most famous example. They could do complex spacewalks, conduct all sorts of research materials, science, biology. And crucially, the shuttle was basically the construction truck for the International Space Station.
Okay.
It carried up most of the major components. So yeah, it was fundamental to building our modern space infrastructure. It helped turn space from just a destination into a workplace. Despite the tragedies, Challenger and Columbia, which taught incredibly hard lessons too.
Which leads us right to that workplace. Maybe the ultimate symbol of working together in space. Our permanent outpost. From Sputnik's beep in '57 to a continuously inhabited global lab orbiting Earth. Quite a journey.
The International Space Station, the ISS, it really is a marvel. Construction started back in 1998. It's the biggest international collaboration in space history. NASA, Roscosmos from Russia, the European Space Agency, Japan, Canada, all partners.
5 major agencies working together.
Yeah, and the result is this permanently crewed laboratory. It's huge, about the size of a football field, end zone to end zone. Weighs almost 1 million pounds, zipping around Earth every 90 minutes.
And truly international inside too, right? Astronauts from all over.
Over 20 countries represented so far. It's this incredible hub of different cultures, different scientific expertise, all focused on common goals, hundreds of miles up. It really shows what cooperation can achieve, even when things are tense down here.
So what's the main point of it? What kind of science happens up there?
Oh, all sorts. It's incredibly versatile. A lot of microgravity research, studying how things behave without strong gravity. That helps us understand fundamental physics, materials, even how human cells grow differently. That has applications back on Earth.
Hmm.
It's also a vital platform for watching our own planet climate studies, environmental monitoring, and maybe most importantly for the future, studying how long-duration spaceflight affects the human body.
Which we absolutely need to know for Mars trips.
Exactly. Understanding how our bodies adapt or don't adapt to months or years in space is critical for planning missions to the Moon, Mars, and wherever we go next. The ISS is our test bed, our stepping stone. It's a symbol, yes, but also a crucial piece of infrastructure for future exploration.
So let's wrap this up. What does this all mean, looking back? We went from that first lonely beep to Gagarin's incredibly brave orbit, to walking on the moon, then building reusable ships, and now this permanent international home in space. It's an amazing arc of ambition.
It really is. And these milestones, they're more than just dates on a timeline, aren't they? They're cultural touchstones. They shifted geopolitics. They sparked imaginations. They show what happens when we push boundaries.
Yeah.
And that legacy is alive and well. You see it in the plans for Mars, the rise of commercial spaceflight making access easier, the Artemis program aiming for a sustainable presence back on the moon.
Hmm.
It all builds on this history.
That inspiration, it's powerful, reminds us what we can pull off when we aim high, tackle the unknown, and actually work together. So maybe the final thought is, what's next? What other uncharted territories, out there or even inside ourselves, can we explore when we harness that same curiosity, that same drive?